All right, let's go ahead and talk about congruence transformations. So congruence transformations are transformations that result in an image that is the same shape and the same size as the original. So it's the same shape and the same size. Okay, so for A, we're going to identify the transformation from the original to the image and tell whether the two figures are similar or congruent. Okay, so here we have A, B, C, and then it goes from A prime to B prime to C prime. Okay, so this is A, this is B, and this is C. This is A prime, C prime, B prime. Okay, so if we're looking at this, congruence transformations, that's going to be either a translation, reflection, or rotation. What does that look like? Does it look like it's being reflected over the x-axis or reflected over the y-axis? No. Does it look like it's being rotated? No, because A, B, and C are all in the same position. What about a slide? Does it look like we're starting here and sliding, which would be a translation? You know what? It kind of does. Let's see if if it goes the same distance every single time for each one of these vertices. So from A to A prime, it goes 1, 2, 3, 4, 5, 6, 7, 8, and then down 1, 2, 3. So that's 3 and 8. Let's see if that's true from B to B prime. 1, 2, 3, 4, 5, 6, 7, 8. That's the same. And down 1, 2, 3. That's the same. What about C? 1, 2, 3, 4, 5, 6, 7, 8, which is the same, and down 1, 2, 3. That's the same. So this is a translation. And the rule for this translation is XY goes to X goes to the left in the negative direction. So it would be negative 8, Y, and then it goes down 3, which would be negative 3. And we want to know if it's similar or congruent. Well, translations, rotations, and reflections are congruent. So we would say triangle ABC is congruent to triangle A prime, B prime, C prime. All right, and that is it. Okay, let's look at this next example here. It says, identify the transformation from the original to the image and tell whether the two figures are similar or congruent. Okay, so what do we have? We have X, Y, and Z. And then this is X prime, Z prime, and Y prime. Okay. So the first thing, we just did a translation. That would be gliding, right? But if you look at this triangle, it is kind of pointing up here, and now it's pointing to the right. So it has totally changed its position. So this would not be a slide, okay? So the next thing we want to look at would be a reflection, right? A reflection over the x-axis would mean that this x would be all the way down, so it's not that. Or a reflection across the y-axis would mean that that x is over here, which it is not. So it's not a reflection of the x or y-axis. So the next thing we do is we want to look and see if it is a rotation. Okay, so what I'm going to do is I'm going to take y, and I'm going to go to the origin here, and then I'm going to take y prime and go to the origin, and that looks like it's a 90 degrees, right? And then it's going from y to y prime, which means that it's going clockwise. So I'm going to go ahead and find that rule. What is the rule for it going clockwise? It was xy goes to, the order was switched, and it was yx. Okay, and I think if I just look at these, then that will help me. So y is, what is y? It is negative 2, 2. And then y prime is 2, 2. So the y goes to the y, and then the x is negative, and then it becomes positive, so that it's a negative x right there. Okay, so that's the rule for a 90-degree rotation about the origin clockwise. So let's see if this is same true for all of the other vertices. So we checked y. Let's go ahead and check x. What's x? It's negative 5, 7. So this is negative 5, 7. So that means that if it is rotated 90 degrees clockwise, it should be 7. The y stays the same. And then the x becomes negative. It's already negative, which means it would be positive. So x prime should be 7, 5. Is it 7, 5, 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4, 5. And it is. Okay, so that's perfect. That works. The last one we have to check is z. Z is negative 5, 2. Which means if it's a 90-degree rotation clockwise, the z prime should be, okay, so the y becomes the x, so it's 2, and then this x becomes negative, and it's already negative, so then it become positive, so it'd be 2, 5. So z should be 2, 5, 2, 5, and that's what it is right there, z prime. So perfect. This is a rotation, 90 degrees about the origin, clockwise. And rotations are congruent with each other. So we're going to go ahead and say that triangle XYZ is congruent with triangle X prime, Y prime, and Z prime. So there we have it right there. Boom. Okay, let's go on to our next example. Example C. Oh, come on. Okay, example C, right here. It says, identify the transformation from the original to the image and tell whether the two figures are similar or congruent. Okay, we can do that. So we have this triangle ABC, and this is the image A prime, B prime, and C prime. It's nice it has the little coordinates there. So let's see what's happening. Okay, we have A, and then we have A prime here. We have B and B prime here, C and C prime here. To me, what does this look like to you? Because to me, this looks like a reflection across the x-axis. And remember that reflection rule, right? It's x, y goes to x negative y, right? So let's see if that's true. So for here, for A, we have negative 2, 1, so that means that the x should be the same, it is, negative 2, and the y should then become negative, which it is, negative 1, so it works there. What about here? We have 1, 4, so this rule, the reflection across the x-axis, says that the x should stay the same, which it is, it's 1, but the y, which is positive 4, should become negative, which it does, so that works for B. So the last thing we have to do is check it for C. Okay, our x part is 3, and that stays the same, and then our y part is 2, and then the y becomes negative. All right, so it works for all three, which means that this is a reflection across the x-axis, and all reflections, translations, and rotations, they are all congruent. The figures are congruent. So we can say that triangle ABC is congruent to triangle A prime, B prime, C prime. All right, there we go. Okay, and on to this next one. So this D, this is a little different. We're moving beyond triangles and looking at quadrilaterals, four-sided figures. So we're just going to identify the transformation from the original to the image and tell whether the two figures are similar or congruent. So looking at this, what do you think? We have A, B, C, D, or A, B, D, C. That would be the way to say it, A, B, D, C. And then we have A prime, B prime, D prime, C prime. Does it look like a translation, a reflection, or a rotation? So if it was a reflection, right, B, if it was a reflection across the y-axis, B prime would be here. If it was a reflection across the x-axis, B prime would be down there. So I'm going to say that this is not a reflection. The next thing to check would be a, what would it be? It would be a rotation, right? Now rotations, like it goes A, B, D, C, it always like kind of flips the order. And all of these are still in the same position, so this is definitely not a rotation. What about translation? Let's see, what's happening from A to A prime? Well, it looks like it's going down 1, 2, 3, 4, 5. Okay, let's see if that's true for B. Does it go down 5? 1, 2, 3, 4, 5. It does. What about C? It goes down 1, 2, 3, 4, 5 again. And lastly, D goes down 1, 2, 3, 4, 5. So this is a translation. It's a translation, and the rule for this translation is that the x stays the same, so we just write x, but the y part goes down 5, so it'd be y minus 5. And then we want to know, is it similar or congruent? Well, every translation, reflection, and rotation is going to be congruent. So I'm just going to say quadrilateral, and we have to go in the order, so A, B, D, C. A, B, D, C is congruent to quadrilateral A prime, B prime, D prime, C prime. All right, and there is our answer. Okay, so this is the last problem that we're going to look at together, problem E. Okay, so we're going to identify the transformation from the original to the image. So this is the original, this is the image, and tell whether the two figures are similar or congruent. Okay, so what do we have? We have translations, reflections, rotations. What do you think? Let's see if it's a translation. So if it was a translation, what are we doing from A to A prime? We're going over 1, 2. Okay, so 2. What about B? We start here and we go over 1, 2, 3, 4, 5, 6, 7. Okay, so it's not a translation because we move 2 units this way. We'd have to move the same units for B, and we're moving like way more than 2. It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So this is definitely not a, a translation. What do you think it is? What about a reflection? So if it was a reflection across the x-axis, A would be down here, right? And it's not, but A is over here. It could be a reflection across the y-axis, right? So A is 1 away, and it's 1 away here for A prime. B is there, and C is there. It could be. Okay, so what is that rule for the reflection? Let's check that. XY goes to negative X, Y for the reflection across the y-axis. So let's see if that's true. So we have our X here, and then for the image, the X should be negative, which it is, and the Y should stay the same. Okay, so that one works. Let's look here for 5, 2. The X should be negative, so it should be negative 5, and the Y stays the same, which is 2. And that works as well. And lastly, let's look here for 4, negative 1. Okay, so for the reflection, 4 should be negative, which it is, and then the Y should stay the same, which it does. So this is totally a reflection. It's a reflection across the y-axis, and all reflections, translations, and rotations are all congruent. So we would say triangle ABC is congruent to triangle A prime, B prime, C prime. And that is our answer. So that is it for this lesson. I look forward to seeing you for the next one. All right, have a wonderful rest of the day.